This is an explanation of how to use the area model, or how I've been using Smart Notebook software to illustrate the area model for multiplication of fractions in the classroom. All these materials plus extras I'll put on the blog so that you can download. This is the actual slide that I use, my opening slide, when I start talking about modeling multiplication of fractions. I use a lot of satellite images. It's a good hook. The kids are interested, especially when it's local images. You can show them where you are in the building and things like that. So I'll zoom in, and I use the back field to start the discussion, and I'll talk about field day, and I'll explain that since we're a middle school and a high school combined, I say we're actually going to I'm actually using a mouse, by the way, instead of the smartboard. So the handwriting is going to be a little messy. It's going to be really messy, actually. I'll tell the kids that we're going to have a field day at the end of the year, and we're going to split the kids up. Middle school on one half of the field and high school on the other. Since I'm teaching 6th grade, they're interested in the middle school piece of it. So I'll tell them, all right, we're going to put you on this half of the field, and we're actually going to take the field and split the field into thirds, and we're going to put the 6th graders on one piece, the 7th graders on a piece, and the 8th graders on a piece. So I'll cut that field into thirds, and I'll tell them that they're going to go on this back piece. Right here. So that's where the 6th graders are going to sit. So they're going to be on half of the field, and of that half of a field, they're actually going to be on a third of that half. So we'll translate that into a number sentence. They'll be on a third of half of the field. And then we'll talk about what is a third of the half of the field that they're going to be on. Well, it's this one piece here out of 6 equal pieces. I guess that's you can see that, but here is one piece. Let's see. Here's the one piece that they're on, and it's one piece out of 1, 2, 3, 4, 5, 6 pieces. So it is one piece out of 6. And then we'll talk about of, meaning multiply, and is in math is our equal sign. So 1/3 of a half is 1/6. 1 times 1 is 1, and 3 times 2 is 6. That has worked. I've used that for the past 3 years or 2 years, and that's worked really well. And most kids in 6th grade instantly get it. It clicks with them for the most part. So then we move to more abstract models. This is 3/5, and we'll talk about cutting it into a thirds or a half. So we might say, what is half of this 3/5? If it were 3/5 of a sandwich and we want to split it with a friend, how much would our friend get? They get half of it. So we can cut it in half, and we can shade the half of the 3/5 of a sandwich that our friend is going to get. And again, I'm using a mouse, and so this is really awkward. And there's no food in this blank space. We can keep shading, but of course this is air that they're not going to be eating. So then we can again come up with our number sentence. We had a 3/5, and we're going to take half of that 3/5. So we'll take 1/2 of 3/5, and a half of 3/5. That product is going to be 3/10. So our friend gets 3/10 of a sandwich, and you can see that the product is the overlap here between our two regions. So we've got 3 equal pieces here. 1, 1, 2, and 3. and it's 3 pieces out of a total of 10 pieces, so 3/10. After that, this is the model that actually represents two fractions, a fraction of a fraction. So this is, I tell them to think about this in terms of rows and columns. So we've got one row here, we've got 2 rows, we've got 3 rows, and 2 of the rows are shaded all the way across. So one of our fractions is 2/3. And then if we look at the columns, we've got 1 column, 2 columns, 3 columns, 4 columns, 5 columns. So a total of 5 columns. And one of the columns has been shaded. So that 1 column represents 1 out of 5, a fifth of our 2/3. So we're taking a fifth of 2/3, and we're getting a product 2/15. The product is represented by the overlap right here, and all of these I've actually made so that you can pull them apart, and it's a little more obvious. So you can see when you pull them apart that our red is 2/3, our yellow is 1/5, and the overlapping region is actually the product. I've got a couple of different versions of it, and I think it's good to show them a couple different versions of the model so that they can get comfortable seeing it. And I've got multiple choice here, which is helpful. This is the same exact thing, except for sometimes it's illustrated by a circle. So you'll say this is, say, half of a sandwich again, and we want to take 3/5 of it. You can tell them to think of that lasso or circle as just shading. So anything that's been lassoed, you can think of it as shading. All of these models are just ones that I've seen on different tests or textbooks. This one here is a little different. So individually, each strip is its own fraction. So you've got 3/5 represented, and you've actually got 1, 2, 3, 4, 5. So without any kind of a lasso, just this image, you could say that this model represents 5 groups of 3/5, or 5 times 3/5, or 3/5 5 times. And then if you actually lasso something or circle it, those are those fractions that you're talking about. So I find this one pretty confusing, but it would be 3/5, and you've got 1, 2, 3, 4 groups of 3/5. So you could say 4 times 3/5, 4 times 3/5. And if you want, you can actually then start and pull them apart and assemble them, so that and of course you pull them apart, not the ones that are outside the lasso, the ones that are inside the lasso, so that you could assemble them, and the product would be those holes. So the product would be 12/5. So as a mixed number, we would have 2 and 2/5. So you could assemble these so that you had 2 whole strips, and then 2/5 of a strip. So again, it's a little tedious using a mouse instead of the board, so I'm not going to go through that, but I think you get the idea. And again, I've got multiple choice for that model as well. So division is one that's not modeled as frequently, I don't think, or that we don't have as many examples, so it's nice to have these. This is an example that I saw, and it worked, so I used it. This could model division or multiplication, which is represented by the model above. Well, each of these strips is a 7. So One thing that this models is how many sevenths fit inside of 4/7. So 1, 2, 3, 4. So it's 4/7 divided by a seventh. So our answer would be D. Here it's the same kind of model on the number line, but I've left a space for multiplication division, so I have the kids come up and come up with either the multiplication problem that it models or the division. So here for multiplication we've got a fourth bar and we've got it 3 times. So it's 1/4 and it's times 3. For the division, it could also show how many fourths are inside of 3/4, and I haven't finished this. 3/4. So for the division, it would be 3/4 divided by 1/4 would equal 3. We've got 1, 2, 3 of them inside of 3/4. So those are the models that I've got. I've probably got 20 or 30 made. Once you make one, you know they're pretty easy to replicate pretty quickly. So I'll post all of them for download. On the multiple choice ones, they have the smart response already programmed with the SOL tagged, so they're ready to go. Hope that's helpful, and if anybody has any comments about how I'm using the area model or any suggestions about verbiage or any other thoughts or ideas or other models that you're using, that would be good. I'd love to hear about them. You can post them in the comments section on the blog. So thanks.